Hello everyone and welcome to this tutorial on dependency mocking. I am making this tutorial because back when I was in university I didn't immediately understand the value of mocking when it was taught to us theoretically. Here's a definition of what a mock object is on Wikipedia. It says here that it's an object-oriented concept, but you can also mock the results of functions, so the general ideas apply to functional languages as well. So mock objects are simulated objects that mimic the behavior of real objects in controlled ways, most often as part of a software testing initiative. And why do we need them? There are some good examples here as to why we need them. First off, we might be dealing with non-deterministic results. For example, we might need some functionality to do a piece of work at a given time, and since that particular time might only occur once every 24 hours, we can't ensure that our tests run at exactly that time, so we can just mock some sort of a time provider to return the exact time that we need. And there's a pretty good example listed down here explaining this exact thing. The second reason is that we might be dealing with something that we can't guarantee will happen, such as network errors, and we're actually going to take a look at an example for this. And the third reason is that the functionality that we're using might be quite slow, and they've given an example of contacting a database, but we'll simulate the same idea with a network call in the example that we're going to take a look at. The fourth thing that they've mentioned here is that the object that we're mocking might not yet exist or might change its behavior. And when working in a team, you might have agreed on a general interface for some functionality. So your work can depend on functionality that implements that interface, but the implementation is still under development by some colleague of yours. Nevertheless, you can still finish your work and make sure that it's correct by mocking your colleague's dependency and testing against that mock. And so far, I've read a sizable chunk of text and it might not be clear why mocking is useful. It was only when I joined the industry that I understood the value of mocking. So with this tutorial, I hope that we can take a look at a simple practical example that's going to make things clearer. I have a video on Kotlin extension functions and mocking their functionality, so this video might also provide some insight into why the ease of mocking extension functions in Kotlin is of value. This tutorial will be in Java though, because it is far more likely that a student would be taught in Java as opposed to Kotlin. So we're going to be taking a look at this example here. Let's say that we are looking for a new chair, and I have prepared a simple static website here containing 5 chairs, where each chair has a name, a price, and a link to some additional information regarding that chair. This is just a simple static website. It is run by a Python server in a directory. And since we're looking for a good trade-off between quality and price, we want to make sure that we only take a look at mid-range chairs in terms of price. But we don't have the time to sit down and look at every single chair listing out of all these 5 listings, so we want to write a program that would automate all of this for us. So I'm going to create a new Java Gradle project for that. Let's wait for it to build. Okay, so the first thing that we need is a way to fetch and parse a website, and to do that we're going to go to Maven and search for JUnit. We're going to grab this HTML parser here and add it to our dependencies. Next, we need to understand what we're scraping. So let's take a look at the DOM of our website. In this case, we can see that we have 5 list elements. Each list element corresponds to a different chair, and each chair has an image, a title, a price, and a link to a more detailed page of that chair. Going back to our project, we first need to fetch the page, and in this case the page is hosted on localhost 8000, so I'm going to create a variable for that. And in order to fetch the page, we're going to use JSoup. We're going to fetch the base URL, and in order to fetch it, we need to call the get method. And I'm just going to handle this exception. And since we're looking for list elements, we need to instruct JSoup to search exactly for that. And in our case, we can do that like so. We're going to get all elements by tag, and in our case we want to get all elements with a tag of li. Next, we need to extract all the relevant information from each share, and I'm going to do that in separate methods. I'm going to start with a title, and in JSoup, an object of type elements can return an individual element. So if we take a look at list items and grab the first one, you can see that the type is element, so that's what we're going to be parsing in our getTitle method. So the title, we can see, resides in an h2 tag, so we can return. We can get all the tags within this element that have a tag name of h2. We need to get the first such tag because this returns a list of tags. We grab the first tag, which is h2, and it's the only h2 tag within every single chair, and then we need to extract the text. And we can actually test that this works. So if we invoke this, we should see chair 1, and that seems to be the case. And if we try to get the first chair and not the 0th chair, we should get chair 2, and so on. And we can move on to the extraction of other attributes. Next, we're going to extract the price. Again, we're going to take in an element. And let's take a look at what the price looks like. Prices are contained within a paragraph tag and look like this. So first we have a price string with a colon, a space, and a $sign, and then the numeric value of the chair. So we need to parse this. First we need to extract the text of our price. Again, we get all elements with a tag of p, and we need to grab the first and only such element, and also grab its text. And next we need to parse into a big decimal. We're going to split the price by a $sign, which I'll escape because the $sign is a reserved symbol in a regex string. And in this case, the second element inside the split array will be the numeric price of our chair. And we can test that this works as well. So we're going to get the price of the first element of all list items. And this should return 1999 once we fix the compilation errors. There's an extra brace here. Okay, so we got 1999 as expected, and finally we can extract the additional details. And we're going to follow the exact same pattern that we did in the other two cases. We're going to grab a specific tag. In our case, we need the anchor tag. And since this returns multiple tags, we need to grab the first one. And this time we won't be extracting its text, but we want to extract an attribute. And that's the href attribute. And since we can see that these URLs are partial, we want to construct a full URL, we can do that by prepending the base URL to the extracted href of the anchor tag. And we can also test that this works. And we can see that we got HTTP localhost 8000 products/chair1, which is exactly what we expected to happen. But as I said in the beginning of this video, we want to filter on these chairs, and in order to do that we need some sort of a data structure. So I'm going to create one. It's going to be a record, and each chair has a title, a price, and some additional information. So I'm going to create a new method here. Which will take a list item and return a chair. And in this case, we're just going to make use of the methods that we've already implemented. We're going to get the title of the list, its price, and the additional information URL. And finally, we can accumulate all chairs within a data structure. So for each list item, we want to call the parsing toChair function and to append that to our chairs data structure. And as we can see, we got 5 chairs starting from chair 1 and ending at chair 5, corresponding to what we have on our web page. Okay, that's all fine and good, but we also wanted to fill the chairs on price. So let's create a method for that. First, I'm going to create our filtering constants. Let's say that we want to look at chairs which are between the price of $20 and $40. And we can write a method that performs this filtering. It takes in a list of chairs and returns a new filtered list of chairs. So we want the lower bound to be less than the chair's price and our upper bound to be more than our chair's price. And finally, we want to accumulate into a list. And if we filter all of our chairs, we should only see chair 2 and chair 3 because they are between $20 and $40. And that's the case, chair 2 price $29.99 and chair 3 price $39.99. This functionality is pretty trivial, but we could be dealing with a more complicated site that requires more filtering that we might want to unit test for correctness. Making an HTTP request to an external website every single time we want to perform a test is probably not the best idea though, because first the test would become very slow. Each HTTP request is a long I/O operation compared to the amount of computation our CPU could do in the same time frame. Secondly, we would be unnecessarily straining the servers of the website we're contacting. In this case, it's okay because I'm simply running a dummy website on my personal computer, so it's not really affecting anyone. Nevertheless, the tests are still dependent on some other process running on my local machine, and that's the Python server here. With proper mocking, we can isolate the unit tests from any such external dependencies. To illustrate this, I'll create a unit test and move all of this logic to the test as a starting point. I'll create a new test. And I'll copy everything we have here over to the test. I need to copy the base URL as well. Handle the checked exception. And I'll change this filter chairs method to public so we can use it in our test. I'll import toChair here. And I'll make it public. I'll also copy the logic for filtering chairs. And at this point, we can start making some assertions. I'm just taking a look at what the result should be. And in this case, we want the first chair that has been filtered to equal chair 2, because it's the first chair that is of price over 20 and under $40. So filtered chairs get 0 should equal this, and if we run the test, this test should pass. Okay, and in addition to this, we want to make sure that the second chair is equal to chair 3 with price $39.99. And we also want to make sure that we have exactly 2 chairs in our result. And the test passed successfully. But again, every single time I run this test, an HTTP request is being made to the website server, and I can illustrate this. If we do a split view like so, if I run the test, we can see that we have a GET request with 200 against the HTTP server. So how do we get rid of this? If I move this to the new line and comment everything else out, we can see that just creating a connection using JSoup doesn't result in any network requests. As you can see, nothing happens on our server. If we add the GET call here, requests start coming in again. So if we make sure that our tests don't call this method, we'll have achieved our task of not spamming the server that we want to scrape. To do that, we need to refactor a bit, so I'll create 2 new classes. The first one is going to be called document getter, and it's going to have a single method that is going to be responsible for returning a document that we can work with. And we need to move the base URL here as well. And we need to handle the exception. So this time I'll just run it with try catch and convert the checked IO exception into an unchecked runtime exception. And now we can move the filtering logic to a new class called chair filterer. So all of this will move there. And we also need to move the lower and upper bounds. And since the base URL is a shared constant between our document getter and our chair filterer, I'll create a new class and move the URL there. I'm going to create a new method in the chair filterer, and I'll call it get chairs of interest. And this method is going to do exactly what our main method did. It's going to aggregate a bunch of chairs into a data structure and filter them out. so that we only get the ones that we want to see with respect to the price. And in this case, we don't want to directly call JSoup and make an HTTP request. That's the whole point of this refactoring. So I'm going to create a new class field here called document getter and a constructor for it. And in this case, we want to use the document getter to get a document instead of directly using JSoup. Okay, so now if we move back to our tests, we can modify the existing test to use the chair filterer. I'll comment most of this out because this logic has now been implemented by the chair filterer. First, we need to create a new chair filterer. And a document getter that we can supply to it. And instead of calling the main class static method, we can use the filterer for that. And now the test should pass once again. But if we take a look at our server, we'll see that it still makes network requests. As you can see, every single test run results in a 200 GET request to our server. So we want to somehow avoid calling the internal functionality of our document getter. We can do that using a library for mocking. I'm going to go back to Maven repository and look for Mockito, which is the library for mocking that we're going to use, and add it to our project. As we already mentioned in the beginning of the video, a mock is a dummy object that simulates the behavior of a real object in a controlled way. In our case, we want to instruct this mock to return a document that behaves as the one that the real document getter returns. So in the standard scenario, we have this, a chair filterer running on our personal computer that uses a document getter, which in turn calls the network card, which goes to the internet, hits the website that we want to scrape, and returns a document back to the chair filterer. What we want to achieve is to get rid of this, so that we have a mock document getter, which we program to return a specific value, and then that mock document getter gets that value from the memory of the computer and returns it to the chair filterer. So I'm going to create a list of dummy chairs that mimic what we have on our web page. In our case, we have chairs with an ascending number, an ascending price, and an ascending URL with additional information. And we can use this list to generate a mock document. To do that, we need to be able to mock individual parts of a single chair. As we can see in our chair filterer, every single chair is represented as JSoup element object. So I'm going to start mocking different parts of our mocked DOM chair. As we said, we want to return an element. And this method is just going to map from a chair object to an element object. And with Mockito, we can create object mocks using the mock method. And we can provide the class of the object that we want to mock. In this case, it's an element object. And we want to mock the title of our chair. The price, and the more info URL. finally we want to return the DOM-chair mock. Okay, so let's start implementing these one by one. I'm going to split the view here and take a look at our chair filterer. So how are we getting the title here? First, we can see that we're getting all elements of tag h2. Then we're grabbing the first element of all the elements. And finally, we're extracting the text from that element. And we can simulate this here in our tests. Okay, so the h2 tag elements will correspond to the return value of this method here, and the h2 tag element will correspond to the first value of the return value of this method here. And we can simulate this with the doReturn method of Mockito. In this case, we want to return the chair's title when the h2 tags text method gets invoked. This here returns the chair's title. And also we want to return the h2 tag when the h2 tag element's first method gets invoked, which corresponds to this part here. And finally, we want to return the h2 tag elements when the base element gets its getElementByTag method invoked with an h2 tag name. So these are kind of reversed. As you can see, first we call element getElementsByTag h2, which corresponds to this line. Then we mock what the result of calling the first method of the result of this operation here would do, which would return an h2 tag. And then we mock the text method's return value of that h2 tag such that it returns the chair's title. And we can do the exact same thing for the mock price and mock info methods. So in the case of mock price, we are extracting all the paragraph tags. And the result of extracting all the paragraph tags is an elements object. That's why we're mocking such an object first. And the first p tag needs to be mocked as well, but it's just an element object in this case, as you can see. Next, we need to simulate the price text to look like this: price colon space $sign and the actual price. And finally, we need to simulate this whole chain of method calls. We want the price text to be returned when the p tags text method gets invoked. We want the p tag to get returned when the p tag element's first method gets invoked. And finally, we want the p tag elements object to be returned when the main DOM chair element gets called with a getElementByTag p method. And finally, we can mock the more info URL. We have to do the exact same procedure here. We have to mock all of the a tags. But instead of mocking the text method like we did before, this time we're mocking the attribute method because that's what we are invoking in this case. The rest of the code chain looks similar to the other methods. We return the first A tag when the A tag's object's first method gets called, and we need to return the A tag's object when the don't-share mock gets called with getElements by tag, and the tag is the anchor tag. Okay, so at this point we can mock an individual list item from here, but we have 5 of these, so we need to mock all of them as a collection. In other words, we need to produce a document object like the one that gets produced by the document getter. This thing here. So in this case, we can see that we are getting all elements by tag of li, so we need to start with mocking these. And we need to generate all the elements, and we already have the functionality for that. For each dummy chair that we have here, we have a mapping function that mocks an element out of it. And since we are running an enhanced for loop here, under the hood the JVM will create an iterator, so we need to mock that iterator somehow. So to do that, I'm going to return the iterator of this list that we created when the mock list elements iterator method gets called. So whenever we enter this for loop here, the iterator method of mock list elements will be called, and this dummy list of elements will be returned, and the result of this dummy list of elements will be filled into our chairs accumulator. And finally, we need to return the mock list elements when the document gets invoked with a getElements by tag li to fulfill this logic here. And now we can modify our existing methods. So instead of creating a new document getter, we can mock one. We also need a document mock because of this method here. And we need to mock its functionality, so we pass the document mock inside the method that handles all of the necessary logic to match our actual parsing logic. And finally, we need to return the document mock when our document getter gets called with getDocument. So at this point, this test should pass. And if we take a look at our web server, we can see that we're no longer making any GET requests. If I revert back to a normal document getter that's not mocked, we can see that we start making GET requests once again. Whenever I go back to the mock, the GET requests stop. We should also be aware that our document getter can throw an exception because it's making a network call, so we might want to test for that as well. Let's say that on a network error we want to return an empty list of chairs. I'm going to write the test first. Again, we're going to use a mock document getter because we can't simulate a network error on demand unless we shut down our Wi-Fi. And And in this case, we're going to use the doThrow Mockito method instead of doReturn, and want to throw a runtime exception anytime we call the document getter's getDocument method. We're going to create a chair filter like we did before and pass this mock document getter that will fail every time that we try to get a document. And we want the filtered chairs of our chair filter to be just an empty list. And if we run this, this should now fail because we haven't really handled the runtime exception that the document getter throws. In order to do that, we need to go to our chair filter, and I'm going to surround this with a try-catch block. And in this case, return an empty list. And now if we rerun the test, it should pass, because we've handled the runtime exception. In fact, both tests should pass, because in the case that we aren't throwing a runtime exception, we're returning a valid list of chairs. And this concludes the tutorial on mocking. I hope it was useful, and I'll see you in the next video. Thank you everyone.